Hello everyone, I am Sujani, faculty in physics at Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss some analytical problems based on magnetic materials and especially on the concepts of magnetization, permeability and susceptibility. So before doing the numericals or the analytical problems, let us discuss a few formulae that are involved with these physical quantities. So first one, what we are going to discuss about is magnetization. So the magnetization is nothing but the magnetic moment per unit volume. So most of the times magnetization is denoted by capital M or mz. In some textbooks they follow the notation mz. And the magnetic moment is denoted by capital M. So here we write capital M is what? Magnetization. And small m here represents the magnetic moment. And V is the volume. V is volume. So capital M is equal to small m upon V. And next we have the magnetic induction B is equal to mu H. B is equal to mu H. B is here the magnetic induction or the induced magnetic field, and H is the strength of the applied magnetic field. H is the magnetic field intensity, I can say. H is the magnetic field intensity. We also have another formula to calculate the magnetic induction B. B is equal to phi upon A. So phi here is the magnetic flux. The flux per unit area gives us the magnetic induction. Phi here is what? Magnetic flux. So flux is the number of lines of force that are passing through a given area. So we can calculate B using phi by A. Then we also have the magnetization M is equal to chi into H, or I can write chi is equal to M by H. Capital M is the magnetization, H is the magnetic field intensity. So more the magnetic field intensity, more the magnetization, and this proportionality constant we are calling it as chi. And chi here is what? It is the susceptibility. Chi is the susceptibility of it. Means the ease with which a material can be magnetized, it depends upon the value of chi. And then we also have another formula for chi. Chi is equal to mu r minus 1. What is mu r? Mu r is the relative permeability. Mu r is relative permeability. So how do we get relative permeability mu r? It is the ratio of the permittivity in the medium to permittivity in permeability in free space. Sorry, it is not permittivity, it is permeability. So mu r is equal to mu upon mu naught. So what is mu here? Mu is the permeability in a given medium, whatever medium we are placing it in. And mu naught is the permeability in free space. We are calling it as mu naught. We also have another formula whenever we are placing it in a medium. You can write B is equal to mu naught into M plus H. B is equal to mu naught into M plus H. So when M is equal to 0, that is in free space, we have B is equal to mu naught H. Otherwise, B is equal to mu H. Now, from this formula, chi is equal to mu R minus 1, we can also write mu R is equal to chi plus 1. So, knowing the value of chi, the susceptibility, we can find the relative permeability also. So, most of the times we'll be using these numericals to solve the problems. So, the first one, find the magnetization of a bar magnet of length 5 centimeter and cross-sectional area 2 centimeters square. The magnetic moment of the magnet is 1 ampere meter square. So, the magnetic moment is given 1 ampere meter square. Length is given 5 centimeter. Cross-sectional area is given 2 centimeters square. We have to find the magnetization. It's a very simple numerical. So, first we'll write the data given. What is the data that is given? We are given the length L is equal to 5 centimeter. Area is also given, A is equal to 2 centimeters square. And the magnetic moment, I'll denote it by small m, is given as 1 ampere meter square. What we have to find is capital M, the magnetization. So, what is the formula we are going to use here? Capital M is equal to small m upon V. Small m is given, but V is not given. V is the volume. So, how do we get the volume? Area into length gives us the volume. So, we have area is given in centimeter square. So, we have to convert it into meter square. So, this will be 2 into 10 power minus 4 meter square. And this will be 5 into 10 power minus 2 meter. So, we will find the volume first. 5 into 10 power minus 2 into 2 into 10 power minus 4. So, this is nothing but 10 into 10 power minus 6, that is nothing but 10 power minus 5 meter cube. This is the volume. Now, what is the magnetic moment M? Is small m, that is 1 by 10 power minus 5. So, when we take it to the numerator, it becomes 10 power 5. So, it is ampere per meter. 10 power 5 ampere per meter, the magnetization. Now, coming to the second one. Find the magnetization. Again, we have to find the magnetization of a bar magnet of mass 180 grams. Mass is given as 180 gram. And the density of the material is 8 gram per centimeter cube. The density of the material is given and the magnetic moment is 3.5 ampere meter square. So, let us write the data given first. We are given the mass 180 gram. We have to convert it into SI system. So, it will be 180 into 10 power minus 3 kilograms. And then we have the density of the material, that is D 8 gram per centimeter cube. This also we have to convert it into SI system. So, 8 into 10 power minus 3 divided by 10 power minus 6 kilogram per meter cube. So, this is nothing but 8 into 10 power 3 kilogram per meter cube is the density. And then the magnetic moment, here I'll represent it by capital M, because for mass we have already taken small m. So capital M here is 3.5 ampere meter square. We have to find magnetization. So I'll represent magnetization by mz. So mz is equal to how much? So what is the formula we have for magnetization? mz is equal to m by v. This is the formula. mz is equal to m by v. M is given, but v is not given. We have to first find the value of v. So we know density is equal to, what is density? Is equal to mass by volume. Density is mass by volume. We are given the mass, we are given the density. So we can easily find the volume. So what is volume equal to? Mass upon density. So what is the mass? 180 into 10 power minus 3. And what is the density? 8 into 10 power 3. So we have got the volume. Now we have to find mz. mz will be equal to the magnetic moment 3.5 divided by, I can take this to the numerator, it will become 10 power minus 6. So into 8 by 180 into 10 power minus 6. So the value of mz we get from here is 1.56 into 10 power 5 ampere per meter. So you can use your calculator to find out these values. So the next one is magnetic field and magnetic intensity are 1.8 Tesla and 1000 ampere per meter. So the magnetic field or the magnetic induction is 1.8 Tesla and the magnetic intensity H is 1000 ampere per meter. What we have to calculate is the relative permeability and susceptibility. Both we have to find. We have to find mu r and chi. So we'll write the data first. B is equal to 1.8 Tesla and the magnetic intensity H is equal to 1000 ampere per meter. We have to find mu r. Also we have to find chi. So what formula we are going to use? So we know we are given B and H. So we will write the formula using the relationship between B and H. So B is equal to mu H, or this is equal to mu naught mu R into H. Because we are given the value of B and H, we have to find mu R. So what will be mu R equal to here? B upon mu naught into H. And the value of mu naught is a constant. What is the value of mu naught? 4 pi into 10 to the power of minus 7 Henry per meter. This is the value of mu naught. So we are going to substitute now in mu r and get the value. So mu r is equal to B, that is 1.8 upon mu naught 4 pi. The value of pi we are going to write 3.14 into 10 power minus 7. This is the value of mu naught into H. H is 1000. So when we simplify, we are getting 1.432 into 10 power 3 ampere per meter. So this is the value we are getting for mu r. Now we also have to calculate the value of susceptibility. So susceptibility chi is equal to what? Mu r minus 1. mu r minus 1. So how do we write this? I'll write the value of mu r as 1432 because it is 1432 into 10 power 3. So we get 1432 minus 1. So it will be simply 1431. Chi value is 1431 which has no units. Now coming to the next problem. The susceptibility of annealed iron at saturation is 5500. So we are given the susceptibility. And we have to find the permeability. We have to find the permeability of annealed iron at saturation. So we'll write the data first. Chi is given as 5500. We have to find mu. So which formula we are going to use? We have to find mu. So mu is equal to mu naught into mu r. Mu naught is a constant, 4 pi into 10 power minus 7. But mu r is not known. But we know the formula for mu r can be written as chi plus 1. Chi is mu r minus 1 or mu r is equal to chi plus 1. Since the value of chi is given, we can easily find mu r. So 5500 plus 1. This is 5501. This is the value of mu r. Now, mu will be equal to what? Mu naught into mu r. So 4 pi into 10 power minus 7 into 5501. This is the value of mu r. So this is 6.9 into 10 power minus 3 Henry per meter. So this is the value of mu, that is the permeability. Now the next one, an iron rod is subjected to a magnetizing field of 1200 ampere per meter and the susceptibility of iron is 599. We have to find the permeability and also we have to find the magnetic flux per unit area. Magnetic flux per unit area is nothing but the magnetic induction. So we'll write the data first. Magnetizing field H is given 1200 ampere per meter. Chi is also given 599. We have to find first mu and then we have to find V. So to get mu, we need to know the value of mu r. So mu r is equal to 1 plus chi. So 1 plus 599. So this is 600 mu r. So to get the permeability mu is equal to mu naught into mu r. And what is mu naught? A constant, 4 pi into 10 power minus 7 Henry per meter. So we are going to substitute this here. So 4 into 3.14 into 10 power minus 7 into mu r value, what we got is 600. So the value is 7.536 into 10 power minus 4 Henry per meter. So this is what we have got for permeability. So once we get the permeability, we can find the magnetic flux per unit area. So B is equal to phi by A and B is equal to mu into H. We have got the value of mu here and we are given H. So just substitute 7.536 into 10 power minus 4 into H is 1200. This gives us 0.904 Tesla. So the unit for the magnetic induction is Tesla. So 0.904 Tesla. Now coming to the next one, calculate magnetization and magnetic field density. If the magnetic field intensity is given and the relative permeability is given. So we have to calculate what? Magnetization and also the magnetic flux density. So we'll write the data. Magnetic field intensity is denoted by H, 250 ampere per meter. And here the relative permeability is given, that is mu r, 15. We have to calculate M. Also we have to find V. So which formula we will use now? First we will get the value of chi. Chi is equal to mu r minus 1. So that is 15 minus 1 is equal to 14. Because we have chi is equal to m by h. So m is equal to chi into h. So m here is, what is the value of chi we got? 14 into the value of h given is 250. So this is 3500 ampere per meter. So the magnetization is chi into h, that is 3500 ampere per meter. The next thing we have to find is the magnetic induction. So what is the formula we have? B is equal to mu naught into m plus h. So B is equal to mu naught is 4 pi into 10 power minus 7 into m we got as 3500 plus h we have as 250. So we have to simplify 4 into 3.14 into 10 power minus 7 into 3750. So when we simplify this, we get 0.00471 Weber per meter square or Tesla. We can also denote it in terms of Tesla. So that is the magnetic flux density. Now coming to the seventh one. Find the relative permeability if H is 220 ampere per meter and M is 3300 ampere per meter. So we'll write the data first. H, here it is given directly. H is 220 ampere per meter and capital M is 3300 ampere per meter. We have to find mu r. What is mu r? So we know the formula for mu r. So mu r is equal to chi plus 1. So first we will find the value of chi. Chi is equal to what? M by h. M and h both are given. So chi is equal to m 3300 upon h is 220. So this is nothing but 15. Chi is 15. So once we get the value of chi, getting mu r is very simple. Chi plus 1. So 15 plus 1, that is 16. So the value of mu r is 16. Chi is 15, it's a ratio, and mu r will be given in Henry per meter. Now the Eighth one, the magnetic susceptibility of aluminium is 2.3 into 10 power minus 5. Find its permeability and relative permeability. Both we have to find here. What is the data given? Susceptibility. Susceptibility or magnetic susceptibility both mean the same. We are talking about the susceptibility of magnetic materials. So 2.3 into 10 power minus 5 is the susceptibility. We have to find mu. We also have to find mu r. Both we have to find. So which formula we are going to use? Mu r is equal to chi plus 1. And mu is equal to mu naught into mu r. And mu naught is what? 4 pi into 10 power minus 7 Henry per meter. So these are the formulae we'll use. Now first mu r. So mu r is equal to chi. What is the value of chi? 2.3 into 10 power minus 5. So I can write it as 0.000023. So if I shift the decimal place, I'll get 2.3 into 10 power minus 5. This is the value of, chi. This is the value of chi we have. Now we have to find mu r. So mu r is equal to chi plus 1. So this will be 1 plus 0.000023. So it is 1.000023 Henry per meter. This is the value of mu r. So once you get mu r, it is easy to find mu because mu is equal to mu naught into mu r. Mu r is the permeability of free space, which is a constant. 4 into 3.14 into 10 power minus 7 into 1.000023. So that is 12.56 into 10 power minus 7 Henry per meter is the value of mu. Now coming to the ninth one. If a magnetic field of strength 300 ampere per meter produces a magnetization of 4200 ampere per meter in a ferromagnetic material, find the relative permeability of the material. We have to find mu r. No, we'll write the data first. What is given? H is given 300 ampere per meter and magnetization is also given 4200 ampere per meter. So we have to find mu r. Okay. So mu r is equal to chi plus 1. This is the formula we are going to use. And how do we get chi given the value? So we have mu r is equal to chi plus 1 and chi is equal to m by h. Chi is equal to m by h. So what is the value of m? We have 4200 and h is 300. So we get it to be 14. So the value of chi we are getting is 14. So once we have chi, we can easily get the value of mu r. Mu r is simply chi plus 1. So 14 plus 1, that is 15. So this is the result. Now coming to the 10th numerical. A paramagnetic material has a magnetic field of intensity 10 power 4 ampere per meter. If the susceptibility of the material at room temperature is 3.7 into 10 power minus 3. So this is susceptibility. we have to calculate the magnetization and the magnetic flux density. So let us write the data first. We are given the magnetic field intensity H, 10 power 4 ampere per meter, and we are also given the susceptibility 3.7 into 10 power minus 3. We have to calculate M, and we also have to calculate B. Okay, so what is the formula we have for M? M is equal to chi into H. We have both the values of chi and H, so we can directly substitute and get it. Now, how do we get the flux density? B is equal to mu naught into M plus H. We are going to find the value of M, substitute here and get the value of B. So, M is equal to chi upon H. So, 3.7 into 10 power minus 3 is M. M is equal to, this is the value of chi upon H. H is 10 power 4. So, M will be equal to 37 ampere per meter. So, this is the value of magnetization, which is 37 ampere per meter. Next, we have to find B. B is equal to mu naught. Mu naught is a constant, 4 pi. 4 into 3.14 into 10 power minus 7 into M plus H. M is 37 plus H. Here is 10 power 4. So, when we substitute and simplify, we get 0.0126 Weber per meter square or Tesla. This is the value of the magnetic flux density or the magnetic induction we get. One more problem, the last one we'll see. The susceptibility of a magnetic material at saturation is 4000. Find its permeability. Very simple numerical. So, the data given here is susceptibility 4000. Susceptibility is given. We have to find the permeability. So, which formulae we are going to use? So, given the value of chi, we can easily find mu r. So, mu r is equal to chi plus 1. Once you get mu r, you can find mu is equal to mu naught into mu r. So, these formulae we'll use. So, mu r will be equal to what now? 4000 plus 1. So, this is 4001 is the value of mu r. And what is mu? 4 pi, that is 4 into 3.14 into 10 power minus 7 is the value of mu naught into mu r is 4001. So, simplifying we get 5.028 into 10 power minus 3 Henry per meter. So, this is the value of mu, that is permeability at saturation. So, for more numericals related to these topics, permeability, susceptibility, magnetic induction and magnetization, you can refer to this link, and also this one to do more numericals or analytical problems on these topics. And to have a clarification regarding the concepts, you can refer to Introduction to Electrodynamics by David J. Griffiths. So, before doing the analytical problems, your concepts of the theory has to be clear. So, for that you can refer to this book, and then for the problems you can refer to these two links. So, thank you and see you again.
Like, share and subscribe. Hit the bell icon for more updates.